Imagine a void so absolute that the concept of light feels like a distant, forgotten memory. In this suffocating darkness, the universe was little more than a vast, cold ocean of hydrogen and helium, stretching out across the infinite reaches of a reality that was still in its infancy. There were no galaxies. There were no planets. There were no eyes to witness the stillness. But then, in a single, violent moment of cosmic defiance, the silence was shattered. A star, massive and ancient beyond our wildest comprehension, reached the end of its brief, chaotic life. It did not go quietly. It collapsed under the weight of its own impossible gravity, triggering an explosion so powerful that it tore through the fabric of the early universe, releasing a flash of energy that would travel across the vacuum for 13 billion years. This was the birth of a phantom. A single burst of gamma radiation and light, carrying the secrets of the very first era of creation, embarking on a journey that would eventually end on the gold-plated mirrors of a machine floating 1 million miles from Earth. For decades, we believed we understood how the story began. We had built our models and our equations on the premise that the early universe was a simple place, composed only of the lightest elements forged in the fires of the Big Bang. We expected to find a pristine wilderness of gas, where the first stars burned with a pure, unadulterated flame. But when the James Webb Space Telescope turned its infrared gaze toward a tiny, unremarkable patch of the sky, it captured something that should not exist. It found a signal labeled as GRB 250314A. At first, it looked like just another flicker in the dark, a faint pulse of energy from the dawn of time. But as the data began to stream into the cooling systems of the telescope and back to the waiting screens of scientists on Earth, the excitement shifted into a cold, creeping realization. The light they were seeing was from a time when the universe was only 730 million years old. That is less than 5% of its current age. By all the laws of physics we have written, we should have seen the death of a primitive, simple giant. Instead, we found a corpse that was far too sophisticated for its era. The light from this ancient explosion had been stretched by the very expansion of space itself, transformed from a blinding violet flash into a long, haunting infrared wave. As it traveled through the expanding void, it passed through the birth and death of countless galaxies, slipping past the formation of our own sun and the rise of life on a small blue planet. By the time it reached the James Webb Space Telescope, it was so weak that it required the most sensitive instruments ever conceived by human hands to detect it. But even in that weakened state, the message it carried was clear. But the radiation readings were just the beginning. What they found hidden within the spectral lines of that light would defy the very foundations of astrophysics and suggest that the history of our universe is far older and more complex than we ever dared to imagine. To understand why this discovery has sent shockwaves through the scientific community, one must understand the sheer scale of the event. A gamma-ray burst is the most powerful class of explosion in the known universe. It occurs when a star many times the mass of our Sun runs out of fuel and collapses into a black hole or a neutron star. In that final, desperate collapse, the star ejects twin jets of matter at nearly the speed of light, piercing through the outer layers of the stellar body and erupting into the void. The energy released in just a few seconds is more than our Sun will produce in its entire 10 billion year lifetime. It is a lighthouse beam from the edge of eternity. When the James Webb Space Telescope caught the afterglow of this specific burst, it wasn't just seeing the light of the explosion. It was seeing the chemical fingerprints left behind in the wreckage. In the standard model of the universe, the first stars were supposed to be made of nothing but hydrogen and helium. These were the legendary population 3 stars, the pioneers of the cosmos. They were expected to be massive, burning bright and hot, and dying young. Only after they died would they seed the universe with heavier elements like carbon, oxygen, and iron through the process of nuclear fusion in their cores and the final violence of their deaths. This process, known as chemical enrichment, was thought to be a slow, agonizingly long progression. It should have taken billions of years for the universe to become polluted with the metals that make up planets and people. Yet, as the scientists analyzed the light from GRB 250314A, they saw a signature that looked disturbingly modern. The light was passing through clouds of heavy elements that had no business being there so early in the timeline. It was as if we had opened a sealed tomb from the Stone Age and found a collection of fine silk and forged steel. The implications of this are staggering. If the universe was already filled with these complex elements only 700 million years after the Big Bang, then our entire timeline of how stars are born and die is fundamentally broken. It means that the first stars we have been searching for might not have been the first at all. It suggests a hidden chapter of cosmic history, an entire generation of stars that lived, died, and vanished before the light we are seeing now was even born. We are looking at a second-generation death in an era that should have belonged to the pioneers. But the presence of these elements was only the first crack in the facade. When the researchers looked closer at the specific ratios of iron to magnesium, they realized that the star that died to create this burst was not just any star. It was a monster that shouldn't have been able to form in the environment of the early universe. Every photon that strikes the detectors of the James Webb Space Telescope carries a story, a code written in the language of the electromagnetic spectrum. By breaking this light apart into its constituent colors, scientists can read the history of every atom it encountered on its journey. In the case of this ancient supernova, the code was telling a story of maturity and complexity. It was showing us a universe that had grown up far too fast. It was as if the cosmos had skipped its childhood and jumped straight into a turbulent, productive adolescence. But how is that possible? How could the universe forge the building blocks of planets and life in a fraction of the time we predicted? As the team delved deeper into the data, they began to realize that the explosion itself was hiding a darker secret. The way the light faded, the specific rhythm of the afterglow, suggested that something was lurking within the debris, something that challenged our understanding of how black holes are born. As we stand on the threshold of this new discovery, we are forced to confront a chilling possibility. Perhaps the Big Bang was not the simple, uniform beginning we once thought. Perhaps the seeds of complexity were planted much earlier, or perhaps gravity behaves differently in the extreme conditions of the early universe. The discovery of this impossible supernova has turned the James Webb Space Telescope from a tool of observation into a tool of investigation, a detective searching for the truth in a crime scene that is 13 billion years old. And yet, the most unsettling realization was still to come. As the analysis of the heavy elements reached its conclusion, the researchers noticed a pattern that linked this ancient death to the very ground we stand on today. The chemistry of this explosion was not just familiar, it was identical to the chemistry of the stars in our own neighborhood. But the search for the source of this heavy metal pollution led to a discovery that was even more baffling. They found that the star which exploded was part of a structure so massive it shouldn't have been able to coalesce in the cooling gas of the young cosmos. And this ancient structure was not a lonely, struggling spark in the dark, but a fully formed, thriving galaxy that defied every simulation we have ever run on our most powerful supercomputers. It was as if we expected to find a scattered collection of bricks and instead stumbled upon a finished cathedral, complete with intricate carvings and stained glass windows. This galaxy, which housed the dying star, was already heavy with the weight of hundreds of millions of suns, all burning with a fierce intensity that illuminated the surrounding hydrogen fog. But it was the nature of the light itself that provided the most disturbing clues. When the James Webb Space Telescope used its near-infrared spectrograph to pull apart the glow of the afterglow, it revealed a chemical barcode that was far too complex. It contained high concentrations of iron, nickel, and magnesium. To an astronomer, these are not just elements, they are the debris of a long and storied past. Iron, in particular, is the ultimate death knell for a star. It is the one element that a star cannot fuse without losing energy, the final brick in the wall that leads to a catastrophic collapse. Finding iron in a star that existed only 700 million years after the beginning of time is like finding a modern satellite orbiting a planet that hasn't even cooled yet. It suggests that the clock of the universe was ticking at a feverish, almost impossible pace, accelerating through billions of years of chemical evolution in just a few hundred million. But the radiation readings were just the beginning. What they found inside the heart of this ancient explosion would lead to a realization that the very nature of gravity in the early universe might be different than we ever imagined. To understand the crisis this creates, we have to look at the hierarchy of the cosmos. Scientists have long searched for what they call population 3 stars. These were the true firstborn, the massive giants forged from the pure, untouched gas of the Big Bang. They were supposed to be pristine, made only of hydrogen and helium, with no heavy metals to contaminate their cores. Because they lacked these heavier elements, they could grow to sizes that are impossible today, some reaching 300 times the mass of our Sun. They lived fast, died spectacularly, and in their final moments, they created the very first heavy elements the universe had ever seen. We expected the James Webb Space Telescope to find these ghosts, to see the pure, blue light of these primordial giants. But every time we look back into the deepest reaches of time, we find pollution. We find iron. We find oxygen. We find a universe that has already been lived in. This discovery suggests that the era of the population 3 stars was much shorter and much more violent than our models predicted, or perhaps, they were born and died in a hidden epoch that occurred even earlier than the Big Bang Theory allows for. It is a mystery that points to a fundamental gap in our knowledge of how matter first began to clump together in the darkness. As the data from the supernova continued to be processed, the researchers noticed something else about the way the star exploded. The energy profile of the gamma-ray burst was unusually narrow and focused. Normally, a star of this age would be expected to produce a messy, chaotic explosion as it struggled with its primitive internal structure. But this event was surgical. It was the mark of a star that had already mastered the art of dying. The jets of matter were so tightly confined and moving so close to the speed of light that they suggest the presence of a powerful magnetic field, something that usually requires several generations of stellar rotation and collapse to develop. It was as if this star was an expert, a veteran of 1,000 cosmic deaths, performing its final act with a precision that should have been impossible for its time. And yet, the deeper they looked into the surrounding space, the more they realized that the galaxy itself was pulsing with a strange, rhythmic energy that seemed to be coming from its very center. But even this precision was overshadowed by a much larger anomaly. When the team measured the total mass of the heavy elements ejected into the void, they found that it was far more than a single supernova should have been able to produce. To get that much iron into the surrounding gas, you would need tens of thousands of stars to have exploded in that exact spot just before this one did. This creates a terrifying timeline. If tens of thousands of stars had already lived and died before the 700 million year mark, then the first stars must have formed almost immediately after the Big Bang, perhaps as early as 50 million years into the life of the universe. This would mean the cosmic dark ages, a period we thought lasted for hundreds of millions of years, was actually a blink of an eye. The universe did not wake up slowly, it exploded into consciousness with a roar that we are only now beginning to hear. But the light from the supernova was hiding an even more radical truth. As the afterglow began to fade, it revealed the silhouette of what lay behind it. The James Webb Space Telescope is more than just a camera, it is a time machine that operates on the edge of the infrared frontier. It captures photons that have been traveling for so long that their original energy has been drained, leaving only a faint, ghostly signature. By capturing this specific supernova, Webb has effectively allowed us to perform an autopsy on the early universe. We are looking at the internal organs of the first galaxies, and what we are seeing is a level of organization and maturity that borders on the supernatural. The gas clouds were not just random clusters, they were structured, spiraling, and already forming the complex webs of dark matter that serve as the scaffolding for everything we see today. The star that died was not a lonely pioneer, it was a citizen of a sophisticated cosmic city. This leads us to a haunting question: if the universe was already this old when it was still so young, what happened in those first 50 million years that we have completely missed? There are theories now being whispered in the corridors of NASA and the European Space Agency that suggest our understanding of the expansion of the universe might be flawed. If space expanded differently in the beginning, or if the speed of light was not always the constant we believe it to be, then the distances we are measuring might be deceptive. But the chemical evidence is harder to ignore. Atoms do not lie. Iron is iron, and it takes a specific set of circumstances to create it. To see it so early is to see a fingerprint left by a predecessor we never knew existed. We are like archaeologists who have dug beneath the oldest known city, only to find another city even larger and more complex buried in the layers below. The mystery of the first supernova has moved beyond simple stellar physics, it has become a challenge to the story of our origins. But as the scientists turned their attention to the final stages of the supernova's decay, they noticed a flickering in the infrared signal that didn't match any known model of a stellar collapse. It was a rapid, high-frequency pulse that seemed to suggest the star didn't just turn into a black hole, it turned into something else, something that was actively consuming the space around it at a rate that defied the Eddington limit. This limit is the theoretical maximum at which a celestial body can consume matter before the outward pressure of the light it creates pushes the food away. This ancient object was breaking that rule, swallowing entire solar systems worth of gas in a matter of days. It was a hunger that shouldn't have been possible in a universe that was still so thin and cold. As we prepared to publish these findings, a new set of images arrived from the telescope's deep field survey. They showed that the supernova we had been studying was not an isolated incident. In the darkness surrounding that ancient galaxy, there were dozens of other flickers, other phantoms, all carrying the same signature of heavy metals and impossible maturity. We aren't just looking at one impossible star, we are looking at an entire forgotten epoch of the cosmos. The universe was already screaming with life and death long before we thought the first candle had been lit. But the most terrifying part of the discovery was not what we saw, but what we couldn't see. Behind the light of the supernova, there was a vast, cold shadow that seemed to be warping the very light of the Big Bang itself. And this shadow was not merely a void, but a gravitational scar left by a progenitor that should not have had the time to grow so massive. It was a supermassive black hole, sitting at the heart of that ancient galaxy, already millions of times more massive than our sun. In the standard timeline of the cosmos, these monsters are supposed to grow slowly, feeding on gas and stars over billions of years of cosmic history. But here it was, less than 800 million years after the beginning, already a titan of the dark. This realization forces us to confront a terrifying possibility. If the stars were already mature, and the black holes were already giants, then the history of the universe didn't start with a slow, cold whisper. It started with a complexity that we are only now beginning to grasp. Every theory we have about the speed of stellar birth and the growth of galaxies is now under fire. We are looking at a universe that was born running, a reality that skipped its infancy and emerged into the light fully formed and ready to create. But the radiation readings were just the beginning. What they found inside the heart of this ancient structure suggests that the very spacetime we inhabit might be built upon the ruins of something even older. As the James Webb Space Telescope continues to stare into this abyss, the data is telling us a story of inheritance. The iron, the oxygen, and the silicon detected in that first supernova are the very same atoms that would, billions of years later, find their way into the molten core of our Earth and the hemoglobin in our blood. We have always said that we are made of star stuff, but we never imagined that the star stuff was this ancient. The atoms that make up your hands and your eyes might have been forged in a violent, impossible explosion that occurred when the universe was still a fraction of its current age. This discovery creates a direct, physical link between the modern human and the most distant, ancient events in the cosmos. We are the living ghosts of a supernova that defied the laws of physics. But as we traced the path of these heavy elements back to their source, we found a pattern in the cosmic microwave background that suggested this wasn't the first time the universe had tried to build itself. There are echoes of structures, faint ripples in the radiation of the Big Bang, that look like the shadows of an entire universe that existed before our own. The sheer scale of this discovery challenges the very concept of the beginning. If the universe could produce a complex, metal-rich supernova and a supermassive black hole in such a short amount of time, then the conditions of the Big Bang must have been far more chaotic and productive than our current models allow. Perhaps gravity was stronger in those early moments, or perhaps the dark matter that holds galaxies together was already organized into a dense web before the first atom of hydrogen ever formed. We are no longer just looking at a map of the stars, we are looking at the blueprints of creation itself, and the ink is still wet. The more we see, the more we realize that the James Webb Space Telescope is not just showing us how the universe began, but how it evolved with a speed and a ferocity that borders on the impossible. The impossible supernova of GRB 250314A is not an outlier. It is a warning. It is a sign that the universe has secrets that it has kept hidden for 13 billion years, and it is only now, through the golden mirrors of a floating observer, that we are finally being allowed to see the truth. But as the investigation into this ancient galaxy reached its peak, the scientists noticed a final, chilling detail. The light from the supernova wasn't just passing through heavy elements, it was being distorted by a force that didn't match the mass of the visible stars. There was something else there, something invisible and massive, that was acting as a lens, bending the light of the explosion around a central point of nothingness. This leads us to the most radical theory of all. If the early universe was already this structured, then it is possible that the Big Bang was not a single point of origin, but a transition, a bridge between a previous reality and our own. The maturity we see in these early stars might be a memory of a previous cycle of the cosmos, a chemical legacy passed down through a collapse and a rebirth. This would explain why the universe seems to have skipped its childhood. It didn't have to learn how to make stars, it already knew. But the search for these primordial memories has led us to a discovery that is even more mind-bending than an ancient supernova. The discovery of this phantom light has effectively rewritten the first chapter of the cosmic story. We are standing at a crossroads in human history, where our instruments have finally become powerful enough to break the boundaries of our own theories. The James Webb Space Telescope has pulled back the curtain on a stage that we thought was empty, only to find a full cast of characters already performing their final acts. This supernova, this ancient death, is the key that unlocks a new understanding of our place in the timeline of existence. It tells us that we are part of a much larger, much older, and much more mysterious narrative than we ever dared to dream. The universe is not a simple machine. It is a complex, living entity that has been evolving and dying and being reborn for longer than our numbers can comfortably describe. And yet, the most profound revelation of all was not found in the light of the explosion, but in what that light revealed about the space that surrounds it. What if I told you that this discovery is only one piece of a much larger puzzle? What if the impossible stars and the giant black holes we are seeing are just the surface of a reality that is far more alien than we can imagine? The James Webb Space Telescope has recently detected something even older, something that exists on the very edge of the observable horizon, dating back 13.5 billion years. It is a discovery that suggests our entire universe is just a small part of a hidden, secret structure that has been lurking in the shadows since the very beginning. To understand how this supernova fits into the grand design of the cosmos, we must look even further back, to a time when the first light was just beginning to stir. Because as it turns out, the James Webb Telescope just found a secret universe from 13.5 billion years ago. Until next time, keep looking up.